first method, gain measurement by direct comparison method. Okay, so this is the setup. Okay, so this is the setup for measuring the gain by direct comparison method. Okay, so see here, this is my arbitrary transmitting angle. This is my transmitting angle. Here, this is power used to measure the power. Okay, I am transmitting. So this is my transmitting angle. I have already told that what should be the separation distance between transmitting antenna and the receiving antenna. Compulsorily, they should be separated by a distance of R is equal to 2d square by lambda. So this is my transmitting antenna. At this side, I have kept two antennas to measure. Two antennas to measure. One is standard gain horn antenna, and the other one is antenna under test. AUT. Antenna under test. Okay, so this is standard gain horn antenna. This is 1 and 2. Okay, so from here the radiation is coming like this. Here from transmitting antenna, you know the power. Here is a power meter. How much of power you are transmitting? That is that reading is noted here. Okay, now we have transmitted this power. Okay, so here initially for one time you connected to standard gain horn antenna. Initially you connected to standard gain antenna and you will measure what is the power received by the standard. That will be P1. Okay, next detach that and now you connect to antenna under test. Now detach that and now you. So initially, so see here, this is my transmitting antenna. This is my transmitting antenna. It will radiate the signals like this. Okay, the power what you are transmitting. Okay, so it is measured here. First, initially, you connect to standard horn antenna and you will measure how much of amount of power that is received here by using standard gain antenna. Let it be P1. Okay, now you will detach it and now you will connect to the antenna under test. Now you will connect to the antenna. Again, you will measure the power P2. Okay, now you will compare this P1 and P2. Okay, so here the first condition. If P1 is equal to P2 means whatever the power received by the standard horn antenna is same as the antenna received by antenna under test. Okay, so no correction is needed. No correction need to be needed and the subject is given by. So the power gain is equal to A2 by A1, where A1 and A2 are the relative power lines. Where A1 and A2 are the relative power lines. Okay, so taking logarithm on both sides, log 10 GP is equal to 10 log base 10 A2 by A1. So log of A by B can be written as log A minus log B. So log base 10 A2 by A1 can be represented as log base 10 A2 minus log base 10 A1 log. So the same thing I can express in GP is equal to GP dB is equal to A2 minus A. Okay. Now, if P1 is not equal to P2 means the amount of power received by the standard horn antenna is not same as the amount of power received by antenna under test. Means you are transmitting the same signal here, but you have received X for this and you have received Y for this. Means this indicates that there is some deviation. So correction to be done. Okay, so if P1 is not equal to P2, then correction to be needed. That is, let P1 by P2 is equal to T, then log base 10 P1 by P2 is equal to PTB. Hence, the power gain is given by, so G is equal to GP into P1 by P2. So already what is the formula for the GP? GP is equal to A2 by A1. GP is equal to A2 by A1. So A2 by A1 into P1 by P2. So G is equal to GP into P1 by P2. Okay, so taking logarithm on both sides. Okay, so log base 10 G is equal to log base 10 GP into P1 by P2. That is equal to log AB can be written as log A plus log A plus log B. So log 10 GB plus log 10 P1 by P2. So G and dB is equal to GP. So this is nothing but power gain GP into dB plus P2. So this is the correction you want to made for the signal. Okay, if P1 is not equal to P2. Okay, so this is the first method. This is the first method, that is gain measurement by direct comparison. direct comparison. So this is the setup for direct first method, direct comparison.